Intense rivalry on and off the ice skating rink tonight. Comedy in thin ice at 10. Now on BBC Two, the temperature gets decidedly chilly in Horizon.
In 30 years' time, they say, Britain's summers could be like the south of France. By the end of the century, we could be as hot as Greece. This, they say, is what global warming could bring us. But a growing number of scientists believe we could have our future climate completely wrong.
I can only describe it as catastrophic. It's clearly going to influence every single one of us every day of our lives.
You could expect to see sea ice off the coast of southeast England, probably several miles offshore.
The implications are huge. The economic implications, the political implications, and the national security implications for all countries.
If these scientists have it right, forget the Riviera. Britain could be heading for a climate like Alaska's. And it could all happen in just the next 20 years. In the Atlantic waters north of Scotland, a fisheries researcher was the first to record a warning from the deep. Bill Turrell has spent his career studying the ocean currents. Until recently, his concern has been how they affect fish stocks.
Okay, we're ready to go.
But 10 years ago, he began to see something in the water that really alarmed him.
We really worried when we saw these results. We'd never seen a change like this ever before. Changes that don't occur quickly and don't stop quickly.
Turrell believes that he has found evidence that a climate catastrophe could be heading right towards us.
These changes are fundamental, they're substantial. They are going to impact our climate and the climate our children have to live in.
If he is right, then Britain could be heading for a massive drop in temperatures. It seems we could be heading for something like an ice age. The ice ages were one of the greatest forces nature has unleashed on our planet.
They simply were the most dynamic, destructive phenomena that's ever hit the planet. They involved glaciers hurtling down from mountainous regions, pouring out from the polar regions, and devastating everything in their paths, grinding rock to nothing, lowering mountains, filling valleys.
More than 20 times in the Earth's history, ice sheets have come down from the North Pole. The last one struck 100,000 years ago. Britain was buried in a tomb of ice.
Effectively, they've wiped the slate clean in the Northern Hemisphere over 20 times in the last 2 million years.
These events were so terrible that for years scientists wondered what had caused them, and could they ever threaten us again? In the search for answers, they turned to the sun our ultimate source of heat. They discovered that the pattern of ice ages matched strange wobbles in the Earth's orbit around the Sun. These altered how the Sun's heat shone upon the Earth. They allowed the ice to grow and retreat.
And these wiggles in Earth's orbit are very regular. They're very predictable. They make sense. And so there's this long, slow, bumpy slide into an ice age and then a climb out of an ice age.
They found that the ice ages didn't happen at random. They followed a slow and predictable pattern. It took 90,000 years to grow an ice sheet and about 10,000 years to melt it. That predictability allowed scientists to calculate when the next one was due. It was reassuring news. Not for thousands of years.
For a big ice age, a big climate change, we don't expect anything to happen on human timescales of a few dozen generations.
The message from the Sun seemed to be clear. We had no reason to fear a massive drop in temperatures. At least, that's what conventional theory said. Then, 15 years ago, Richard Alley came to Greenland to study how our climate had changed since the last ice age.
When we started working in Greenland, we knew we were on to something big. We really expected that we were going to find things that might surprise us.
Greenland is like an ancient thermometer, a unique record of what has happened to the weather every single year for the last 100,000 years. It's all because the ice is preserved in layers. The further down you drill, the older the snow.
If you took all these pieces of core that have been collected and put them end to end, they're about 2 miles long, and this is a sort of 2-mile time machine.
Each layer records what was happening in the Earth's atmosphere at the time the ice was formed. Whether it's the traces of a huge natural disaster or pollution from human activity, it's all frozen and perfectly preserved.
We can see that this ice core is beautifully layered, and we can ask of it what happened, what was coming through the atmosphere at that time. Is there ash and acids from a big volcano? Is there lead from Roman lead refining, or what have you? So there's this history of what was blowing through the air and piling up on top of the Greenland ice sheet, sitting here in these beautiful layers.
But the most important measurement preserved in the layers is the temperature. The ice that Ali brought back to the lab was, in effect, the annual weather reports since the beginning of the last ice age. What he was looking for was changes in the amount of so-called heavy water held in the ice. The basic rule, the more heavy water, the warmer the climate. If the conventional wisdom about climate change was true, then when he plotted the results, he would expect to see slow changes in heavy water as the world warmed and cooled during the last ice age. But that's not what he found.
This flabbergasted us. I think this flabbergasted a lot of people.
The changes were anything but slow. He saw that temperatures could drop suddenly and catastrophically. And it happened far more often than was predicted by the pattern of ice ages.
The world sometimes did change in these slow, grand sweeps, and sometimes it changed like a light switch.
The Earth's past was full of devastating climate jolts. None as bad as a full ice age, but enough to turn Britain into Alaska. The search was on to find out what could trigger these climatic disasters. They searched through the ice record for clues. Had huge volcanoes blotted out the sun? There was no evidence for that. A succession of asteroid impacts? Again, no evidence. More wobbles in the sun's orbit? That didn't fit. In fact, no one could account for what Ali had discovered. Except for one man who thought he could. Wally Brocker is the guru of climate science. He was convinced that it was all to do with the oceans.
I'm convinced that the ocean is at the core of the whole thing. The trigger lies in the ocean.
Not everyone saw it his way.
And of course, you start out with 3 allies and 100 people who think it's nuts.
Brocker's attention was drawn to one ocean current in particular, the Gulf Stream. Britain bathes in its heat. It begins south of the equator, and as it flows along the Gulf of Mexico, it absorbs heat from the tropics. It continues on past the coast of Britain.
It's roughly equal to all the rain in the world. 15 million cubic meters per second.
The current carries the heat of 1 million power stations. It means we can swim in the sea at the same latitudes that Canada has polar bears. But the most important thing about it happens further north. It sinks.
When it gets up into the northern reaches of the Atlantic, cooled and made denser, and it sinks into the deep sea and goes back the other way.
This sinking is caused by salt in the water. When the salty water cools near Greenland, it becomes so dense that it plummets to the bottom of the ocean. The water then heads back south to where the Gulf Stream began, and the whole process begins again. It's a continuously circulating belt of water and heat. That's why it's called the conveyor. The sinking off Greenland is vital. This is what keeps Britain forever warm. So Wally began to speculate. What would happen if the conveyor ceased to flow? Could that explain those dramatic falls in temperature? Trouble was, most scientists were convinced that the oceans never changed at all.
People tended to think about it as something that went on and on and on and on. We assume that the properties of the ocean are at steady state, but if it's changing, then you can't assume that anymore, and it makes real chaos.
Then came something that shook everyone out of their complacency. Something so small, it might have been completely overlooked. Lloyd Kegwin spends his time examining mud samples from the bottom of the ocean. Mud cores, just like the ice in Greenland, can tell the history of activity in the ocean and what was going on in the conveyor. In particular, Keigwin was looking for tiny seashells called forams. These lurk on the ocean floor, feeding on nutrients that sink to the seabed.
The forams build their shells out of calcium carbonate like any seashell you'd find on the beach. And when they take carbon and oxygen and other elements out of the water to make their shell, the chemistry of their shell reflects the chemistry and the physical properties of the water.
When the conveyor flows, most of the nutrients get swept past the forams, and so their shells are usually poor in nutrients.
When the conveyor is on, the deep water of the North Atlantic is continually being flushed out, and there aren't a lot of nutrients that have accumulated. But if the conveyor went into an off mode or a reduced mode, more nutrients would accumulate.
Keigwin developed a way of measuring how much nutrients the forams must have absorbed.
We add a little more liquid nitrogen here, and this trap will capture the carbon dioxide produced as this sample falls in the hot acid. And soon we'll know, was the conveyor circulation on or off at this particular time.
To his surprise, he found massive variations in the composition of the shells. In other words, at times in the past, the conveyor must have switched off. When this work was published, Wally Brocker knew exactly what it meant. It was the clue he had been looking for.
The greatest joy to a scientist is discovery. It's almost as if nature is trying to prevent us from uncovering her secrets.
So he put it all together. The huge drops in temperature seen in the Greenland ice, the shells that said the conveyor had been cut off. They had to be connected.
Well, it was just merging two parts of my science, the understanding of the ocean and the understanding of climate. It popped into my head that one way you could do that would be by turning on and off what's now called the conveyor belt, the deep water formation in the North Atlantic. And so I got the idea, well, hell, if you turn that on and off, or up and down, that could make, at least in Europe, very large climate changes.
Brocker believed this explained the massive jolts in temperature seen in Greenland. The conveyor had switched off.
We can only apologize to passengers for the inconvenience caused and the disruption to services this morning.
And if it had happened before, it could happen again. And if it did, Britain would be plunged into a bitterly cold climate. But then someone pointed out one obvious flaw in the theory. This isn't the age of global cooling, but of global warming. 8 of the 10 warmest years on record fell in the last decade. Climate experts are predicting temperatures to rise faster than at any time since the last ice age.
The models that are used to make these predictions of global warming suggest that by the end of the century, the warming we would see will be between about 1.5 degrees and around 6 degrees. And really to see that in historical context, you'd have to go back hundreds of thousands, maybe even millions of years to see a climate in the past that was that warm.
the effects of global warming are being felt across the planet. The talk is not of ice, but about how to prepare for hotter weather and the extremes that will bring.
Global warming should make the UK a more hazardous place to live, particularly during the winter when we have not only more rain, but we have more heavy precipitation, bursts of extreme rainfall. This is going to mean that, for example, river flooding is much more common, much more frequent, and its implications will be much more serious.
There'll be changes in frequency of things like tropical cyclones and possibly storms in the outside the tropics, in the sort of latitudes of the UK and Europe.
These are the changes our government is urgently planning for in the coming century. But recent discoveries suggest we might have to gear up for ice, not heat and rain. That our understanding of global warming may be too simplistic. One of the most important of those discoveries was made by a team of NASA scientists based inside the Arctic Circle. Bill Crable and his team have spent the last decade monitoring the effect of global warming upon the vast Greenland ice sheet.
This particular area, you can think of it as a huge ice cube that nicely buffers global climate. An ice cube that's 1,000 miles long, 400 miles wide, and 2 miles thick in the center.
For years, accurate measurements of the effects of global warming across the ice sheet were impossible. It was just too huge and inhospitable to measure from the ground. So they took to the air. Greenland is one of the biggest blocks of frozen water in the world. And if it started to melt, the effects would be felt worldwide.
It comprises enough water to raise sea level by about 6 or 7 meters if it all were to melt.
How much we get over here? We get all this done.
They map the ice with a combination of global positioning satellites and lasers. The satellite measures the height of the plane, and the laser measures the distance from the plane to the ice.
But there are 5,000 individual beams per second that are being projected into that scan mirror and then down in a pattern on the surface, measures the surface to 10-centimeter accuracy.
At 5-year intervals, they have flown the same route across the island. Each time they have measured the height of the ice. By comparing the two measurements, they can see if the ice is growing or shrinking.
There's definitely changes taking place here. All over the margin of the Greenland ice sheet, it is thinning. It's equivalent to 50 cubic kilometers of ice and snow that are disappearing off the Greenland ice sheet each year.
This 50 gigatons of water melting from Greenland was the first evidence that global warming might be affecting the ice sheet here. But one change really shocked them. They started to measure one of the island's biggest glaciers.
Less than 10 years ago, 5 years ago, it was moving at about 6-7 kilometers per year. And that was more or less in balance with the snowfall. Now, in the 5 years since then, the speed has almost doubled.
It's now advancing at 12 kilometers a year. The increase seems to be linked to global warming. It's the fastest moving glacier on the planet. It dumps enough fresh water into the sea each day to supply London for several months. Global warming seems to be reshaping the whole landscape of one of the biggest ice sheets on Earth.
Well, I myself am convinced that global warming has affected the dynamics of the Greenland ice sheet. And that is possibly because increased meltwater is creeping to the bed through crevasses and moulins and lubricating the bed and making it far more easy for the ice to flow.
NASA have recently doubled their estimates of how much fresh water is coming off Greenland to 100 cubic kilometers per year. And much of that fresh water is flowing towards the sinking zone of the conveyor. Scientists began to wonder just what could be the effect of all that fresh water on the conveyor. They began to realize that because the conveyor was driven by the salty water sinking, then too much fresh water would dilute the salt. And so if the salt was diluted too much, the conveyor wouldn't sink.
What's amazing about this is that how well fine-tuned the system is. Where only a 1% change in the salinities may be significant, may tip us over into this regime where the water is too fresh at high latitudes to sink and the conveyor will stop.
Cut off the conveyor and a climate catastrophe would happen. The only question was, just how much fresh water would it take? The truth is that no one quite knows. What they do know is that Greenland isn't the half of it. There is another, even bigger source of fresh water heading straight for the sinking zone. Predictions are that global warming will lead to a much wetter world, because warm air can hold more moisture. And when it heads north and cools, it should lead to more rain. In 2000, a team of American scientists traveled to Siberia. They studied the effects of global warming on some of the biggest rivers in the world.
If you took the Ob, the Yenisei, and the Lena rivers and put them side by side, you'd have a volume of discharge equivalent to 3 Mississippi rivers.
The rivers collect rain that has fallen over a vast area of land. They already carry nearly 20 times the amount of fresh water towards the sinking zone than drains from the ice in Greenland. Peterson wanted to find out if global warming had led to more water in these rivers. The warming in the last 100 years is only about half a degree. He measured how the flow of water had changed.
An increase in annual discharge of 128 cubic kilometers per year. You probably cannot imagine what 128 cubic kilometers a year is like. It's a large volume of water.
And in the coming century, we're expecting up to 10 times more global warming. So Peterson decided to calculate how much more fresh water that could bring.
At the end of the next 100 years, we expect approximately 50% increase in the discharge of these rivers would occur.
It's a horrifying prospect. A 50% increase in some of the world's biggest rivers. If Peterson's projections are true, a vast wall of fresh water will soon come flooding through northern Siberia. An extra 1,000 cubic kilometers a year more could flow into the salty waters of the conveyor. The impact could be immense. And that was the warning that Bill Turrell had seen in the deep. He's been monitoring the saltiness of the conveyor as it flows past the Faroe Isles north of Scotland.
This is the device we use to measure the salinity in the ocean. These bottles here collect the water, the samples that we bring back to the ship to analyze, to calibrate the electronics, which are down here. This package measures temperature, salinity, about 25 times a second as we lower it down from the surface down to the seabed.
If the saltiness of the water is dropping, it's a sign that the driving force of the conveyor is weakening.
This graph shows the salinity or saltiness of the bottom water. It's the saltiness from 1900 to the present day.
Until the 1970s, the salinity had been almost constant, but then it began to drop.
After the late 70s, we began to see a freshening of the bottom water. So much so that we began to doubt our own results. We took further samples, we checked with other countries who were sampling the same water, until eventually we became convinced that this change was actually happening.
Turrell had measured the largest and most dramatic change recorded in the era of modern instruments. And there was worse. He took measurements from the very bottom of the ocean, from the return leg of the conveyor. Its flow had fallen by a massive 20%.
It's the first changes that we'd expect to see if we thought that global warming was beginning to affect the conveyor belt. A few years ago, I probably wouldn't have said that because global warming was far more iffy. It wasn't so significant, it wasn't so certain. Now we really do know that freshwater input to the Arctic is increasing. The Siberian rivers are pumping out more fresh water. The Arctic ice sheets are melting and there is more release of fresh water. It's the most fundamental change I've observed in my career.
The process that could cut off the conveyor has begun. We don't know where the cutoff point is. We just know we're getting closer to it.
I don't think that an abrupt, sudden trip and fall down the stairs is the most likely outcome. But I think that the probability of that is high enough that we should really think about it.
The likelihood of having an abrupt change is increasing because of global warming is moving us closer and closer to the brink. We don't know where that is, But we know one thing, we're moving towards the edge. And so I would say within the next 100 years, it's very likely, in other words, a 50% probability, that this might happen.
So there could be a 50% probability that the conveyor will stop flowing past the shores of Britain. Perhaps a 1 in 2 chance that one of the most important sources of heat in the world will just disappear. What would happen to us if the heat of 1 million power stations were to cut off? The answer depends crucially on how soon it happens. The Met Office has run a series of possible scenarios. In the first, they examined what would happen if the conveyor cut off in 50 years. They have balanced the effects of 50 years of global warming against the regional cooling caused by the conveyor cutting off. In this scenario, the area around Britain does indeed get colder.
Cooling due to the ocean circulation collapse is even stronger than the global warming. We're still looking at a climate which is a lot colder than today's.
But how much colder? This was the coldest winter in the past century. A freak event, not easily forgotten.
The winter of 1962 to 1963 is something that people of my age particularly remember because from Boxing Day till March, there was very deep snow on the ground across much of England.
Blizzards lashed the country for day after day. In places, snow lay 8 meters deep. And temperatures fell to minus 22 degrees.
That winter had a huge impact on people's lives. There's a lot of disruption to all sorts of infrastructure. People were snowed in for long periods over quite a wide part of the country.
The electricity supply failed across the whole southeast. Crops had to be drilled out of the ground. We asked the Met Office to examine their scenario and calculate how often we could expect a winter like this. Their answer, once every 7 years. But there is a second scenario the scientists have been examining.
Well, I can only describe it as catastrophic.
The implications are huge.
It's clearly going to influence every single one of us every day of our lives.
The economic implications, the political implications, and the national security implications for all countries.
This scenario is that the Gulf Stream conveyor cuts off not within 50 years, but 20. It's described as a low probability, high impact event. The whole of Northwest Europe gets a lot colder.
This is really a huge change in climate, a massive cooling. If this were to happen, we would certainly have a future which was very cold, very different from what we have today.
The coastline of Britain would become unrecognizable.
you could expect to see sea ice off the coast of southeast England, probably several miles offshore.
We would struggle to keep our coastline open and our ports working. But the effects of a shutdown could be even greater on land. Winter blizzards would bring us entirely new hazards.
We'd expect to see ice storms. Now these are severe winds, but they bring with them either frozen rain or snow, which clogs up and builds up on cables, power cables, telephone cables, brings them down very effectively. These conditions can persist for days and can really bring a country to its knees.
Our infrastructure would be in danger of collapse.
The power lines would ice up, they'd snap, they'd collapse, and this could happen virtually countrywide during the worst of these storms.
With enough warning, we could make plans and adapt to our new landscape. The trouble is, there wouldn't be any warning.
It'll be quick. And suddenly, one decade, we're warm. The next decade, we're in the coldest winter that we've experienced in the last 100 years, but we're in it for 100 years.
Winters like this would be commonplace.
I think we'd be extraordinarily poorly equipped to deal with a Gulf Stream shutdown. If we're dealing with a situation where snow is on the ground for perhaps 30 days a year or maybe up to 100 days a year, where temperatures are regularly down in the -20s, I think we'll find it very, very difficult to cope with that.
It could mark the end of the British way of life as we've known it. But there is something even more disturbing about the conveyor cutting off. Something that suggests it could cause a catastrophe of truly global proportions if it were to happen. The Met Office have run another computer simulation. It shows a clear link between a conveyor cutoff and patterns of rainfall across the world.
One of the things that really surprised us was the fact that the impacts are not just confined to our part of the world.
The dark red areas of his map suffer massive drops in rainfall.
The main rain band in the tropics would move quite a bit south, so all these countries in the red region here would lose a very large proportion of their rainfall, and that could impact on a large number of people in those parts of the world.
Central America would be one of the worst hit regions. It could lose up to 40% of its rainfall.
The model suggests that the present vegetation, the rainforest, wouldn't be sustainable in that situation, and the forest would die and be replaced by grassland.
While we shivered through long and bitter winters, huge tracts of forest would die away. Well, that's what the computer model said. And then came evidence that it had actually happened before. The clues came from within Richard Alley's ice cores. They contain bubbles of ancient air, evidence of how the atmosphere has changed. Alley's attention focused on one gas that was present in the bubbles: methane. It's produced naturally by bacteria in the tropics when they receive plenty of rainfall. And it disappears at times of drought.
And so you can go and ask of those bubbles, how many swamps were there on Earth? And this is wonderful because it tells you something that's happening across a whole bunch of the land area. If the world dries up partially, there'll be much less methane in the air, and it will show up right there.
He found that the methane levels plummeted at the same time as temperatures had dropped in the past. It seemed a conveyor cutoff made the world drier.
And when the North Atlantic has been cold in the past, the monsoon seems to have weakened or failed in places in Asia. You chill out the Northern Europe and you dry a lot of places where a lot of millions of people live now.
The monsoon is a lifeline to hundreds of millions of people living across the Asian subcontinent. Agriculture depends on its heavy rains. Should this scenario ever happen, it would bring disaster on an unimaginable scale. There would be famine, economic collapse, and refugees on the move.
We had only 3 billion people on this earth in 1962. We have over 6 billion now. Where are these people going to go if they're economic hard time? If we were to get on the same scale of the Irish famine today that occurred then, I am very concerned what would happen at that time.
And there is a final twist to these scenarios. Switching the conveyor off can happen at speed. But switching it back on is altogether harder.
We're moving along, and suddenly we drop down. How did we switch it back on? Well, we'd have to climb this cliff. There's an enormous amount of energy required to climb that cliff.
And there'd be nothing in the meantime we could do to change it.
We have to reverse this effect of global warming by hundreds of years.
We are now preparing for more heat and more rain. But our new understanding of how climate change works challenges all that. It suggests our defenses could be pointing the wrong way.
On Thursday, Horizon investigates the lost civilization of Peru, which ruled 2,000 years ago and then mysteriously vanished. That's Thursday at 9 on BBC Two. And tonight on BBC 4, scientists attempt to defy the ageing process in Time at 9.